So today we're going to talk about arithmetic sequence and how to insert arithmetic means between two given terms in the sequence. So we are still going to use the main formula of the arithmetic sequence, which is the a sub n equals a sub 1 plus n minus 1 times the d, wherein the a sub n is our nth term of the sequence, and of course our a sub 1 is the first term, and the d there is the common difference between the terms. So we will have the first example. We will be inserting 5 terms between 9 and 51, and then the second one will be to insert 3 arithmetic means between negative k plus 1 and 7k minus 7. So that's quite a complex example. So for number 1, insert 5 terms between 9 and 51. So that would mean that, of course, we have to insert 5 terms between 9 and 51. So that means our 9 is the first term, and then there will be 5 terms to be inserted between 9 and 51. So 9 is our first term, and our second term, third term, fourth term, fifth term, sixth term are going to be the arithmetic means that we're going to insert from 9 and 51. So 1, 2, 3, 4, 5 terms to be inserted between 9 and 51. So as you can see, 9 is our first term and 51 is our seventh term. So we can actually use these details, this information, to identify the arithmetic means that we're going to insert. Now the process is we need to find the common difference, because we already have the a sub 1, which is 9, and of course our 51 here is our seventh term, so we can actually use the 51 as our nth term here, and that would mean that our n here is 7 and our n here is also 7. So using the formula, a sub n equals a sub 1 plus n minus 1 times d, we will let 51 as our of course we will use the 51 as our nth term, so 51, and of course our first term a sub 1 is the 9, and since 51 is the seventh term, so we're gonna use the 7 for n, and our objective is to solve for d. Simplify the terms now. We have 51 equals 9 plus 6d, and then 51 minus 9 equals 6d. So 51 minus 9 is 42, and then of course to solve for d we still have 6, so divide both sides with 6. 42 divides 6, so the common difference, or the d, is equal to 7. So since we now have our difference or common difference 7, we can just simply add the 7 to the first term 9 and add the same number towards the succeeding numbers, and you will obtain the 5 arithmetic means. So that means our second term is of course a sub 1 plus the difference, which is 7, so that's 9 plus 7, so your a sub 2 is equal to 16. Doing the same process, our a sub 3 is of course a sub 2 plus d, which is our a sub 2 is already determined, which is 16. 16 plus 7, and you're going to have 23. So 23 plus 7, you're gonna have 30, and then 37, and then 44, and then 44 plus 7 is equal to 51. So our answer is correct. So we now move to our second example. We are going to insert three arithmetic means between two terms, but in this case, our two terms are expressed in expression. The first term is the negative k plus 1, and the last term of the sequence is 7k minus 7. Still using the same process, our negative k plus 1 is going to be our first term, and we are going to insert three arithmetic means. So that's 1, 2, 3 arithmetic means between negative k plus 1 and the last term, which is 7k minus 7. So that also means that our negative k plus 1 is our first term, and then we have a sub 2, a sub 3, a sub 4 as our three arithmetic means to be inserted between the negative k plus 1 first term and the 7k minus 7. It turned out that that is actually the fifth term of the sequence. So still following the same concept and using the same formula, we use the formula a sub n equals first term plus n minus 1 times the d. Okay, so as you can see, we will be using the first term, negative k plus 1 first term, for the a plus 1 here, and we are going to use the 7k minus 7, which is actually the fifth term for our a sub n in the formula. So for a sub n, we're going to use the fifth term, 7k minus 7 equals, our first term is right here, negative k plus 1, and then plus, and our n of course is the fifth term. Our 7k minus 7 is the fifth term, so our n here is 5 minus 1 times the d. And this is just simply simplifying expression. So 7k minus 7 equals, this one will become 5 minus 1, this will become 4d. So I'm gonna have negative k plus 1 plus 4d. And what I'm gonna do is to cancel out the terms here except the d. So I'm gonna somewhat like transpose these terms to the other side. 7k minus 7, and the negative k is plus k in the left side, and the positive 1 becomes negative 1 on the left side, and retaining the 4d only on the left side. So 7k and k is 8k, and of course negative 7 and negative 1 is negative 8, equals 4d. Remember, we have to solve for d, and we still have 4 and in the right side, so basically we just have to divide everything with 4 now. The same with the terms on the left side. So 8k divide 4, and also 8 divide 4. So this one is now d, and 8k over 4 is 2k, and our 8 over 4 is also 2. So our common difference is in a form of expression. So our d is equal to 2k minus 2. Now to determine our second, third, and fourth term, so this will be our process now. For our second term, of course, it's simply a sub 1 plus our d, and our first term is of course the negative k plus 1, and we are going to add the d, which is 2k minus 2. So let's simplify that. Let's take out the parentheses, the grouping. So negative k and 2k is k, and of course our 1 and negative 2 is negative 1. So our second term is k minus 1. So our second term is k minus 1. K minus 1. To solve for the third term, that's simply a sub 2 plus d. And of course, our a sub 2 is already determined right here. So k minus 1 plus the difference, which is 2k minus 2. So you're going to have k and 2k is 3k, and negative 1 minus 2, they're both negative, so that's negative 3. So this is now our a sub 3, or the third term. So our third term is already determined, so that's 3k minus 3. 3k minus 3. To solve for the fourth term, that's a sub 3 plus d, and our a sub 3 is of course right here, 3k minus 3, and our d is 2k minus 2. 2k minus 2. In simplified terms now, 3k and 2k is 5k, and negative 3 and negative 2 is also negative 5. So this is now our a sub 4. And our fourth term is 5k minus 5. 5k minus 5. Now to check if our answer is correct, we continue the process. Our a sub 5 is actually a sub 4 plus the d. We're going to add this to our common difference. Let's try to check if the answer is 7k minus 7. So 5k minus 5, that's our fourth term right here, plus the common difference, which is 2k minus 2. 2k minus 2, and 5k and 2k is 7k, and negative 5 and negative 2 is negative 7. So that is our fifth term. So as you can see, our fifth term obtained is 7k minus 7, and the answer is correct. So our three arithmetic means are k minus 1, 3k minus 3, and 5k minus 5. That's all for the arithmetic means. Thank you for watching.
I'm walking alone the street.